Today's session, we're going to be covering the flurry of announcements that have come from MS Ignite. For those that may not be familiar with Ignite, it's kind of our IT Pro targeting conference. It's a second one. We have Build in May timeframe where we kind of release early developer previews, but Ignite is really where all the big announcements for most of folks come in, and we wanted to make sure that we share the information that we glean from it to enable you all to best be able to take advantage of that. Next slide, please. So we have a pretty packed agenda today. We are going to be covering a number of different areas. We have three presenters with us that will introduce themselves as we're going through these presentations. Derek, please advance to the next slide unless I'm the one that's lagging here. Wanted to make sure that you guys are aware of the upcoming sessions. We'll paste those into the chat as we go through the presentations here today. And please do ask your questions in our Q&A panel. And also, if there's any topics that we cover, we're going to cover so many different things in great brevity today. Please drop those into Q&A chat so we can use those to prioritize whatever sessions may be coming up next in January, because we're going to move to a weekly cadence for this particular webinar. So with that, I'm going to hand things over to Jeremiah for the first segment. Jeremiah, the floor is yours.
Thanks, Tom. So hi, everybody. My name is Jeremiah Guthrie. I will be giving about 10 minutes on some of the major AI announcements from Ignite. So buckle up. There's going to be a lot of content. We are trying to slam about 3 days worth of announcements into an hour. So let's get started with kind of a refresher. Those of you that might have attended Build should be familiar with this slide, but Microsoft has a distinct opinion on how apps in the age of AI would be created. It's this kind of Copilot stack. It would be helpful as we talk through some of the announcements that cover some of these layers to expand a little bit more on what we mean as definitions, right? So at the very bottom, we have the infrastructure, and on top of that runs these things called foundation models. Foundation models come in a variety of different flavors. We'll talk about those immediately after this section. But above that is kind of this concept of orchestration, which is where the magic of kind of copilots are. So things like grounding, creating your meta prompts, and creating your prompts themselves. And so we're also going to look at some tooling announcements that was pretty exciting coming out of Ignite about some enablement and some kind of centralization of a lot of these tools to make the process of developing copilots a little bit more straightforward. Moving swiftly on, foundational models. So for those of you that watched OpenAI's Developer Day, you'll know that they announced a myriad of new GPT-4 models, including multimodal. Given our partnership with OpenAI, we are quickly following suit, putting these into the kind of more enterprise-friendly confines of Azure, where you have things like managed identity and some of our content and safety features that we'll talk about here shortly present. And so as of today, GPT-4 Turbo and DALL-E 3 are available in limited previews across limited regions, with the multimodal GPT-4 Turbo with Vision coming before the end of this calendar year. The next is a particularly exciting announcement, in my opinion. So there's a lot more LLM models out there than just OpenAI. And so this model as a service, I think, was a little bit of a stealth announcement that actually has a fairly large impact. So what's happening is we are collaborating with not just the open source community, but other providers of models as well, to offer up that same kind of provisioning experience that you get with using our OpenAI service for other model types. So the first one to be available in this model as a service methodology is Meta's Llama 2, with the ones that you see there following on quickly. And so when you see some of the slides that come next, just remember that the tooling that we were looking at there doesn't just apply to OpenAI. Models that you're seeing on this slide will actually also be pluggable into that same set of tooling. Next up, AI orchestration. So just kind of a repeat into where we're at in the overall layer cake. The first major announcement is Azure AI Studio. And so for those of you that have been playing with our tooling for a while now, you'll notice that depending upon where you're coming at your development journey, you had different places that you had to go for different tool sets. So if you wanted to interact with the OpenAI models, well, then you've been in Azure AI Studio for a while now. But if you were using, say, cognitive search, you had to go over to a completely different experience. Or if you were going to, say, do some work with prompt flow, which is also something we'll talk about here in a couple of minutes, that was over in Azure ML Studio. And so Azure AI Studio is envisioned, it's not there yet, but it's envisioned as this unification, this platform unification, to be able to provide everything you need for creating generative AI driven apps. So things like controlling your data integrations, so linking out to OneLake, linking out to Fabric, linking out through cognitive search, right, to other places where you would do retrieval of content, managing the full application development lifecycle. So things that were natural for traditional deterministic developers now moving into this world of generative AI, testing and kind of outcome testing becomes a very big thing. And so Azure AI Studio provides some capabilities to be able to do bulk testing to make sure that the flows that you develop survive the outcomes you're looking for over generations as you refine prompts, as models change. And then finally, a single place to manage safe and responsible AI features. Moving on, Azure AI Search, not necessarily a brand new announcement, but more of a rebranding in recognition of expanded capabilities. And so Azure AI Search is the new name for Azure Cognitive Search. But with that rebranding comes two key features that make it more applicable and more useful in the age of building AI applications. For those of you that have been building some of those already, you'll be aware that grounding, creating your prompts is extremely important. But also, if you want to ground your AI in your own data, then the retrieval augmented generation pattern becomes also very important. And for those of you that have tried implementing that pattern, there's actually a bit of a challenge to it where, much like a human using a search engine, you have to sometimes go back when the results aren't relevant and refine your search. And so these features in Azure AI Search provide a mechanism to constantly be able to improve the results that you're getting back. So the addition of a vector to the query or the search index allows you to be able to do intent-based searching. But one of the powers of Azure AI Search is that you can actually combine models. So you can do this concept of hybrid searching, where you use keyword searching and you use vector searching to be able to get you a broader, but hopefully more specific result set. And then this idea of search ranking with semantic ranker comes in to be able to then look at what your query intent was against the result set that came back, and then potentially reorder the result set so that you're only receiving the higher confidence level ratings. There's some research out there I won't bore you with, but you can go check it out. It does about a quarter of a full point better in most retrieval cases than either standard keyword search or standard vector search alone. Next is Azure AI Prompt Flow. So I've mentioned this a couple of times. We don't have a lot of time to dig in deep to it, but what I will tell you is for building a generative AI workflow, being able to visualize it, seeing the inputs and outputs of each step, debugging it, and then running bulk testing, this is a wonderful service to look into. It's been around since Build, where it was previously in Azure ML Studio. It's being moved over as part of the preview into AI Studio. But the capabilities continue to see a lot of refinement here. You can bring your own orchestrator libraries, so you can use LangChain, you can use semantic kernel, and be able to kind of create a full end-to-end flow. And it is a nice golden path to take you from that. And then it offers a lot of deployment opportunity to be able to then host it in other Azure service types. Next, but certainly not least, is Azure AI Content Safety. So these are particularly important tools. So I mentioned that, at that lower level, you've got the infrastructure and you have foundation models. And I've kind of promised that, today, I'm sure any of you using the OpenAI service are familiar with the content safety and how it applies. That content safety and the fact that we control those API endpoints, even for model as a service, means that the content safety filters can actually be applied not just to OpenAI models, but also to those models as a service as well. And so what that ultimately looks like, and this is a pretty helpful, in my opinion, diagram to kind of demonstrate what we're kind of talking about here. But say I've got a customer application and a prompt comes in, and I make that request out to the LLM. Before the response actually comes to you, it passes through content safety, which is tunable. So the things that it's filtering out are, hate speech. Well, you can kind of see the things that are down there, but what it will ultimately do is it'll return you an error code in the body that will basically tell you that the reply was not something that met our content safety standards or the ones that you tuned it for. One thing to kind of take note of with content safety is there is a floor minimum. So in the service, you can only turn it higher. You can't really turn it down further or turn any of these off. So just something to kind of call out there. With that, I believe we will transition quickly to Steve Moss for data announcements. Steve, I'll keep advancing slides. You just give me the Vanna White heads up and I'll do that for you, okay?
Okay, that sounds great. Yeah. So again, thanks, Jeremiah. What I'm going to attempt to do is also go through a lot of things, but trying to add some value, like Jeremiah did, to rather than just read off some things, give you some insights about what these products are and how they can be of value to you and context. So if you can go ahead and advance the slide. So these are some of the things that were GA. There's more than this. We're going to get to some more, but just it's a huge amount of things. This first kind of list of generally available things of OneLake Data Factory, Synapse Data Engineering, et cetera, and the one shortcuts is really the announcement of Fabric going GA. And so Fabric is our data platform, and I have some slides to kind of explain that, hopefully quickly, to what it is. It is not really I've heard people think, oh, I thought it was a rebranding of other stuff or is just is marketing. No, it really is a re-architected integrated platform. And certainly we're using technologies that have been out there but have been enhanced. And on top of that, adding a lot of new technologies and letting AI everywhere and ability to also interact with other clouds and everything. Now, and so next slides, we'll get into that a bit. The Copilot, a public preview, and data activator are some new things that we have. So Copilot is really, there's Copilots pretty much everywhere in Fabric for helping you do data wrangling, for helping understand the context of your data. It can automatically create reports like in Power BI. And, so it's, it can do quite a lot of things and more to come, but obviously it's harnessing the natural language capabilities of our models, but built into the fabric, as it were, of our products. And Data Activator is a new tool basically to, you may have also heard of it called Reflex, but it's basically to do alerts on data and alerts on different kind of scenarios. So we won't go into that a lot, but that's also a new capability that's built into Fabric. Now, really quickly on the private previews for mirroring. So what we're offering is mirroring of these services, which is basically a change data capture into Fabric of SQL, but also Snowflake and Cosmos DB. And so basically, and we're handling the compute cost and the storage costs of those. Those come to you so that you can integrate and have the data in one place to do data science, and to also integrate with your other data. So if you could move the slide. So this is a quick one, and maybe keep clicking through the automation. I'm sorry, yeah, the automation wasn't working, I guess. If you go back maybe one, sorry. This is fine. So this is kind of just an overview of what is in Fabric. Again, it is a re-architecture. It is a platform, but basically it has on the bottom of it, basically, OneLake, which is like a open data lake for multi-clouds as well as Azure. So we have shortcuts and things. There's a security layer, of course, and then universal compute capacity. So what you do is you buy compute for all these things at once, and you can use them and allocate them. And there's a shared workspaces ability to share, and everything is AI assisted. And maybe the next slide gives a little bit more context to this. So really, what we have is this basically built on Delta Parquet format, which is open source. That's what we're storing the data in. You can store other data, obviously, but to make all these different compute engines work, the Delta Parquet is kind of the universal storage format. But once it's in there, basically, then we have different engines. We have basically a T-SQL engine that can work with the same data, Spark. You can share it and use any of these engines and to use with your data. And so there's also the shared universal security model. And so it really is a way to not have to deal with integration, but also to have a kind of a data in one place without data movement and still be able to use the right tool for the right job, as it were. Yeah, if we could maybe, there's some animation, but go ahead, please, to the next slide. Oh, there we go. So yeah, that kind of that kind of shows the kind of the things. Basically, you can have the storage into different workspaces for different business uses, for customer 360, for finances, and then you can use the right tool for the right persona and the right work task. So next slide, please. So this is one of the things also, another engine that was developed. So our SQL engine was developed was an enhancement to the Polaris serverless engine. The Power BI has also a new engine built into it with Fabric called Direct Link. And what Direct Link is the ability of basically using Power BI as a database directly over the Parquet Delta files. They realized that that the Vertipack engine of Power BI is basically similar to the Parquet Delta Lake format. And so what that enabled our engineers to do was to rewrite the engine so that it doesn't have to, it pulls in the data into memory when it needs it and washes it out just like a SQL or Oracle database, a relational database would do. And so what this means to you is that you can store everything in Parquet Delta Lake and be able to do blazingly fast, as like import speed fast on large amounts of data, and without having to process it or import it or refresh it. So it's another kind of breakthrough engine. It's not, again, just some hooking up to Delta files. It's a rewrite of the engine for that purpose. So next slide, please. So I mentioned this, I wanted to do this slide very briefly, but this is, there's concepts, if you're buying capacity, you may wonder, well, how does that benefit us? One of the things it can do is this smoothing, which is basically we're allowing these workloads to go past what you've purchased and to basically smooth the time. So it will allow this bursting and smoothing and auto scaling throughout your capacities so that your jobs will run and that you'll be able to, but not have to over provision for little spiky peaks, so that you have to do basically have to provision for peak load. You have to provision for more average load. So this is kind of a way to save money, and also to get your jobs to run, to get the extra power when it needs it. It will grant that. So this topic we could go into a lot, but just so you know. We also mentioned copilots everywhere. So Power BI is part of the copilot experience. Power BI can do data exploration. So basically, the new copilot features of Power BI are able to create reports and also to adjust the visuals and layouts. And you can see that combining that with that direct link can have a huge impact. So this is an example of a report created just using Copilot against your data. You just create your model, and it can create some decent reports which you can edit. And if you go to the next slide, it can also do summarization of the insights of the report. So things that both executive summaries or likely questions from leaderships, et cetera. So it's really another amazing aspect of implementation of AI that we have. Next slide, please. So we haven't forgotten, all the other databases, that we have also. So, I mean, one of the things is that there's a pricing relaunch of Hyperscale, and there's also enhanced manageability for SQL Server on-prem and in other clouds, and basically to have visibility and management of all your servers, even on-prem in Azure. There's also announcements of Azure Database for MySQL business critical performance enhancements. And there's an Azure DB for PostgreSQL extension for Azure AI. And so there's a link there to the breakout session. Next slide, please. So Hyperscale, the announcements are basically lower pricing, which is that you can save up to 35% on compute. So it's basically predictable pricing with no IOPS charge, and there's competitive rate on low latency local SSD storage. And so again, so it's enabled some value for this Hyperscale. And really quickly for Hyperscale, if you're not familiar, the next slide, I just wanted to introduce that to you because I think it's one of our breakthrough tech. Well, it looks like I don't have a slide, but Hyperscale is kind of a breakthrough technology also where we've decomposed all the different aspects of a cloud database to allow it to scale from small to hundreds of terabytes and from one core to like many cores, and also have a lot of reporting, secondaries, and backups like instantaneously. So you might look at the architecture of that if you for a cloud database. Next slide, please. So again, we're talking about the SQL Arc. Arc for SQL Anywhere can monitor. Now, there's announcements for monitoring your estate in Arc. Monitoring also always on availability groups for your SQL DBAs and people for high availability, and other aspects. So all your estate can be, and it's a lot of these things are free for the Azure Arc. You add the agent to your on-prem. And other ones you can add enhanced security with our advanced Defender security for very small fees for that too. So you might look into that to manage your on-prem estate if you don't have the ability to migrate to the cloud, if that is at the moment. And I am running low on time. Maybe there's also this business critical enhancement for MySQL, and I think really that's basically all we have time for. There's some more slides, but I think that you get a feel for the level of the enhancements and innovation and the speed of innovation on Azure with data. So thank you very much. I turn it back to Jeremiah.
Thanks, Steve. So I'm gonna transition pretty swiftly, and there's quite a lot here to kind of try to pack in here, which is packing is actually going to be a theme of this part of the presentation. So I'm going to cover the announcements related to what we at Microsoft call our application innovation solution area. I think the SKUs in that will be obvious as I go through, so I won't belabor what that means. The first is kind of a bread and butter service. So Azure App Service had a couple of important but not really headline announcements. So the first is the ability to be able to do multiple app service plans into a single subnet. This is a really important one because subnet sprawl and IP exhaustion becomes a really kind of hard problem if you've really committed to a lot of app services. And so one of the use cases here is, say you have a dev test environment where there's less security reason to have separation. You can pack multiple app service plans into that single subnet. The next is a kind of a parity thing. So a long time now, web jobs have been a thing for Windows-based app services. It's been brought to Linux, which is, in my opinion, pretty important. The next is extensibility support. So this starts out in Linux, and at some point, hopefully, will wind its way to Windows-based ones. But the idea here is that you can run effectively sidecars. So the kind of canonical example for this one would be if you run an app performance management tool like a Dynatrace. It's typically been hard, other than picking up external signals, to figure out what's going inside of that inside the host. This extensibility support allows more native deployment of those kind of probes directly into the app service. And then end-to-end TLS support, and then I'll kind of move on. But this one's important also for those of you that deal in highly regulatory environments. Up until this point in and out of service plan, TLS has always been decrypted at the proxy, and then it goes down to the actual workers inside the host cluster in HTTP. With this new feature, you actually, for Linux-based hosts, have the ability to go TLS the whole way end-to-end. Next bit, very lightly touch on this one, but also very important. For those of you that deal with app estates where you have a lot of things remaining on-prem and you kind of shudder at what it might take to put it in the cloud, the .NET and the Java app migration assessments, really important. So these aren't kind of like looking at the server like normally the Azure Migrate tooling does. These are actually looking at your code and will point out things in that code and will assess the readiness of that code base to be repackaged for different app targets. So container apps, Kubernetes, app services, the works. And so pretty powerful stuff. And for .NET, it's run directly out of Visual Studio. For Java, there's actually a separate tool based on the Windup project. Very cool stuff. Next up, container apps. So this one's also kind of an interesting one. Like, this has been a burgeoning service for us. It's basically, for those of you not familiar, it is container orchestration without the nastiness of trying to manage a Kubernetes cluster operationally. And so in keeping with some of the announcements in the first part of this presentation, you know, with the big focus obviously on being able to do inference models and run inference models, container platforms are very often a target, if not always a target for that. And so for those of you that have a desire to run custom inference models, maybe that your data science teams are creating, a lot of these features should be kind of stand out for you. So one is the ability to be able to do kind of an easier code onboarding. What this does is look at an asset that's been produced, say a jar file, and it will actually create the assets necessary to run it in a container app. So it'll create the Docker file and it will push it to an app container, or I'm sorry, to push it into a container registry. And it'll put all of the Docker file and kind of the manifest stuff back into the source repo that you basically have the asset come from. GPU enabled workloads, as I kind of mentioned, the ability to be able to specify a need for a GPU capability for your inference model. And then finally, vector DB add-ons. So add-ons are an interesting one in container apps because what they are meant more for is pre-production deployment. Obviously, in a microservices environment, you take a lot of dependency on external services. And oftentimes, if you're running a full Kubernetes and you're, you know, an ecosystem, maybe you've deployed things like, let's say you want a vector database. And so maybe you've deployed Pinecone as the kind of full open source project. But, you know, that's great for development. But as you move up the stack and go to production, unless you're going to develop a competency to be able to maintain a Pinecone vector database yourself, you may want to swap that out for a kind of an enterprise solution that does the same capability of vector indexing, but with some type of a support backing. And so this add-on is for development grade prepackaging of things like Pinecone. So in lower environments, you can save costs by developing against these open source projects, with the idea being that those extensions kind of run out of road at the end of development, and you would move to something more weapons grade, enterprise grade, whatever you want to call it, by the time you move to production. Very interesting one for those of you that are kind of big integration shops and dealing with maybe kind of some of the noise around BizTalk. So logic apps have long been kind of the integration answer, along with a series of other tools, Service Bus, API management, even Azure Data Factory, to a point of kind of the Azure integration story. And so the challenge has always been those are a little bit disparate. You know, they're deployed as individual resources, and sure, you can group them into a resource group, but when you're trying to explain to your business what flows kind of support them, it's not always easy unless you've been really good at things like tagging. And so Azure Integration Environment is a new service. It's more like a container where you can add resources to it. And then one of the nice pieces of it is once you brought those resources in currently this kind of public preview, logic apps are the only ones that actually register with this, but you can actually take those different logic apps and what they do, and you can have a business process engineer sit and actually create a process flow and then map those process flows to the different logic apps that are executing those stages. And there's actually really nice tracking dashboarding where you can kind of watch in real time as those business processes are flowing. you kind of raising up into this UI that's part of the integration environment. Generally available is Azure Logic Apps Data Mapper for Visual Studio Code. So the data mapper has been kind of a thing for a while now in Logic Apps, but this ability to be able to deal with it inside of Visual Studio Code is a nice addition, in my opinion. So it allows you to drag and drop between a source and a destination, much like any of you that have done classic ETL work before. It's going to be very familiar, but it allows you to create those kind of maps and then reuse them potentially across other Logic apps. And the idea is you can do these in Visual Studio Code, so you get some of the benefits of that being a familiar development environment, and then the ability to be able to version control. We're going to spend a lot of time, or I guess the next 7 minutes here. November happens to be a 2-event month for Kubernetes. So one is Ignite, and then the other is KubeCon. So a lot of the stuff you're going to see here was kind of a co-announcement. So 3 big things that we're going to focus on. This is kind of going to be the agenda for the next 7 minutes, but we're going to touch on Azure Fleet Manager, pretty important, but often under the radar service. Some things in the cost management space, which is always important to talk about because Kubernetes can be sprawling. And then finally, what would a section of this be without talking about AI? So let's start with Fleet Manager. Fleet Manager is really intended for customers who run a lot of Kubernetes clusters and have felt the pain of managing those clusters. So let's say that you are a globally distributed company and you're running a cluster on, in Europe, and you're running another one in the US, but the workload is effectively the same. To date, you've had to use something like hopefully you were using GitOps to kind of deploy those, but you had different pipelines for those different clusters. Also, if you ever wanted to kind of go and say upgrade your Kubernetes clusters, you were managing that all yourselves, sort of one cluster at a time. And so Fleet Manager allowed you to have this kind of concept of a fleet hub, and then you join clusters to it. The idea being that anything joined to that particular fleet, those are going to be mirrorable workloads, right? And so what that gives you the ability to do then is store your configuration. So you can do configuration propagation for your deployments. You can ensure your network rules are the same across it. You can ensure your security rules are the same across it. And you're managing it from one central plane. And then Fleet Manager is taking care of making sure it is replicated out to those clusters. This is actually most obvious when you start talking about things like multi-cluster update. And so for those of you I've spoken to, and maybe those of you that have spoken to other TSPs, CSAs here at Microsoft, you often hear about Microsoft's progressive deployment process. So this idea that you have lower environments and you put your code there first, and then it goes out to another ring where there's maybe some live users on it, but they can suffer higher disruption. And then it goes to kind of an Azure region, and then, out to the kind of the global Azure regions. And then there's a rule in place where you never go to both region pairs at the same time. Multi-cluster update gives you that power and that capability, but managing it for Kubernetes. So the way this diagram is kind of to be read is you've created an update group or an update stage for test. And inside of test, you've got 4 clusters, but you've got 2 different groups. These groups can be upgraded in parallel, this one and this one. But inside of those groups, these clusters are upgraded in sequence. And so this upgrade group won't actually complete if the second upgrade fails. And then that would actually fail the whole state. And so it gives you kind of some more deployment safety that hadn't been very easy to achieve prior. The next bit. So the next couple of slides are about cost monitoring or cost optimization. AKS monitoring, this is actually kind of unique. I've not seen this on many other services, but obviously with everything streaming out of AKS, container logs, container metrics, node logs and metrics, the footprint in Azure Monitor can actually get to be very expensive. And so this AKS monitoring allows you to be able to tune at the source what you want. So frequency, what namespaces, how long you store particular tables, and then this idea of more basic logs. So it's a wonderful thing to explore if you're trying to kind of optimize your observability in AKS, but also have some cost consciousness. Next bit, if you're running Container Insights, there is a workbook that I would encourage you to go take a look at. It will actually tell you things like, and it's based on kind of live data in Monitor. The important one for this cost optimization is you can actually see how much of the limits and requests your pods are actually using. So if you take a stab at what your Kubernetes request is for your particular pod, and you say, give me half a millicore and 4 gigs of RAM, you can actually see how much is being used, right? And so in that case, you can get to this point of being able to bin pack a little bit better. So pack more containers per node, because you have the ability to actually see what you're really using and scale back those requests to kind of make your cluster more efficient. AKS cost analysis. So this is actually based on an open source project, but this kind of will give you the ability to see by namespace potentially how kind of costs are being sliced across your cluster. So if you are running a shop where you do internal IT chargeback, this is definitely something to take a look at, because you can share a cluster across business units, but still be able to have accurate bill back to your internal cost center. Node auto provision, won't touch on this for very long, but this is super important. This has been a feature that's been requested for a long time. Over in AWS land, they had a project called Carpenter that they hadn't really open sourced. That's since been donated to the CNCF. And so the AKS team is moving quickly to be able to bring this in as a managed extension. So the real quick and dirty of what Carpenter does is it actually allows, it is exactly what it says. It does node auto provisioning. And so it will look at kind of what needs to be scheduled, and it will pick from a series of templates that you can configure on what is the right size next node. So unlike a current AKS model where you've got node pools that are homogeneous, right? So I might have a particular VM scale set for one node pool and then a different one for another. This node auto provision actually allows more node pools to be joined, but of more variety. So it's a pretty important project. Very important if you're trying to optimize kind of density in your cluster. Finally, and I've only got a few seconds left, but we're actually making pretty good time. The machine learning aspect on AKS. So if you have been using Azure Machine Learning in the past, there's been a pretty good story. You had a single place where you build, train, validate, deploy, and monitor your model. And one of your deployment targets could be Kubernetes. And you were happy, right? But what happens if you have a data science team that was basically building their own model and you weren't using Azure ML to do it? Well, then this was your user experience to try to deploy that on Kubernetes. You basically had to do everything yourself. Pick your image, make sure it had the right GPU, make sure the networking for the GPU was big enough or had enough bandwidth, set up the inference API, and then kind of like troubleshoot your quotas and stuff. The AI toolchain operator for AKS actually handles a lot of that for you. So it's based on a custom resource definition for this concept of a workspace. And it gives you the ability to be able to use a custom resource definition to tell the cluster, look, this is the type of GPU I want to use, and I want to use internal hosting for this particular LLM model. And what it will do is not only create the deployment and make sure that it places it on a node that can support the workload, kind of going back to that node auto provisioner, but it will actually also give you an API endpoint that can be used inside of that cluster or potentially exposed outside of it. So that you have the ability to take, say, a Falcon model, Falcon 7B model, and sort of have your data science team tune that and then deploy it into this in minutes rather than weeks. And then I'll just leave you kind of looking at this because I need to hand off to Freddie here. But there were a bunch of other announcements. So Kubernetes event-driven auto scaling, the announcement of 1.28, some important stuff, Azure stack, like dual stack CNI overlay. If you haven't looked at CNI overlay, you need to. Pretty important. But yeah, a lot of stuff here. I know I went through that incredibly quickly, but if there's any questions, toss them into the Q&A and I'll do my best to kind of answer them. Freddie, over to you.
All right, well, thank you. Now we get into the Azure infrastructure side of things. And thanks, Jeremiah, for all that information. And of course, in the infrastructure side of things, we typically get new VMs, faster VMs, and GPUs and things like that. But now, this time, we are in the world of AI, so we are also getting a Copilot. So the Microsoft Copilot for Azure was announced. And let me move this away. And the Microsoft Copilot for Azure is an AI companion that helps you design, operate, optimize, and troubleshoot your cloud infrastructure and services. So what it does is it combines the power of the large language models, or LLMs as we know them, in the Azure resource model, and it gives you the ability to be able to understand everything that has happened in Azure. So Copilot answers questions about the cloud environment, and it gives you that ability to do it faster and easily. So the Copilot helps you understand invoices, spending patterns, changes that are happening in your environment, and also outliers. And it also recommends cost optimization, things that you might be able to do. So it helps you visualize things in Azure, in the Azure environment that in the past used to be a little bit complex. If you do a lot of things with Azure Graph Explorer, the Microsoft Copilot for Azure will be able to help you create those queries that you can use in the Azure Graph Explorer, such as if you're doing queries to find out how many Azure Arc enabled servers you have, that the Copilot can help you do that much quicker than you were doing it before. So it's a very exciting announcement. If you haven't seen it yet, I would recommend that you go to this webpage here and you can go ahead and sign up for the preview, and you can start using those those features at this point. Next, Microsoft announced the use of the hollow core fiber technology, which enables fast, reliable, and secure global networking. This is a new type of fiber that is delivering a 47% improvement in speed over traditional fiber, because if we get into the weeds, as I said, because the photons are able to travel through the microscopic air capillaries instead of solid fiberglass. So what that does, it reduces signal loss, and it also lowers attenuation, which enables more data to be transmitted at higher speeds, effectively increasing the bandwidth. And because of that ultra low latency and lower signal loss, this also means that signals can be transmitted over longer distances without the need of repeaters, and this allows data center placements to be closer to our customers. So this is already, it has been deployed in some of the data centers in the UK, and is also moving to other regions as well. So this is a great announcement. This is helping our customers, have more data or more bandwidth between locations. Going to the VM side of things, the virtual machine side of things, we recently announced the GA of our industry-leading NDH100 virtual machine. This is powering the world's most complex workloads. And in our most recent submission to the top 500 ML Perf benchmarking list, we're proud to announce a #2 rank on the top 500 supercomputer list. We're the only provider in the top 50. We're there 6 times. And again, we ranked #1 in cloud and #2 overall in that ML Perf list. Microsoft also announced the preview of a new NCH100 V5 virtual machine series. This is built on the latest NVL variant of the NVIDIA Hopper 100 GPU, which offers greater memory per GPU. Our new VM series provides customers with greater performance, reliability, and efficiency for that mid-range AI training and generative AI inferencing. So this is a great announcement. Also, the announcement of the H200 GPU to market and our ND200 V5 virtual machine series. Now, this was based on customer feedback. Excuse me. This virtual machine series is optimized for large language model inference and can support larger models and more inferences with the same latency as our H100 VMs as well. Great announcements. Also on the AMD side of things, the NDMI 300X V5 virtual machine with the AMD chip for optimized chips for generative AI workloads. This one is designed to accelerate the processing of AI workloads. This is using the AMD GPU MI300, specifically designed for deep learning and training of large language models. So this one is available in the NDMI 300 V5 VM system. And moving on to the Other announcements, Microsoft announced the Azure Cobalt, which is the first CPU series designed by Microsoft and optimized for the Microsoft Cloud. The Azure Cobalt, excuse me, leverages the ARM IP for exceptional performance per watt efficiency. The Cobalt 100 is the first in the series, and it is designed with a focus on performance per watt and features built-in power regulations and dynamic voltage capabilities so that we can tune the per core performance and power consumptions for a wide range of potential workloads and needs. It is built on the modern process technologies, which is the TSMC 5 nanometer technology with 128 server cores, 12 channels of DDR, and running at high performance. So this is another one that is a great announcement for the chips. And we also announced the first fully custom in-house AI accelerator series called Azure Maya, starting with the Maya 100, which is designed for running cloud AI workloads. When we talk about Maya, Maya is a chip that is manufactured also on the 5 nanometer process and has 105 billion transistors, making it one of the largest chips that can be made with the current technology. It is designed for optimal training and inferencing efficiency across the Azure OpenAI workloads, and this includes GitHub and GitHub Copilot and Bing as well. So Azure Maya servers are designed with a fully custom Ethernet-based network protocol that gives you 4.8 terabits per accelerator. So this enables better scaling for end-to-end workloads as well. So when we look at the Maya, Maya is essentially two shelves. So when we look at the server itself, Maya essentially is two shelves. The bottom shelf, which hosts the CPU, the RAM, the networking, and the management capabilities. And the top shelf houses 4 of the Maya 100 AI accelerators, and each chip is directly connected to the Tor networking. So the Maya servers are designed with fully custom Ethernet-based network protocol with an aggregate bandwidth of 4.8 terabits per accelerator. And this enables better scaling for those end-to-end workloads. And they're also built and manufactured to meet the zero waste commitments to ensure that the era of AI is also an era of environmental sustainability. When we look at the Maya is more than a chip. It's a fully integrated system with self-contained liquid cooling to deliver the optimal performance and efficiency. Here you can see the Sidekick heat exchange unit that cycles the liquid from each server in the rack through a single radiator. So it just gives you a better view of how that works. And this self-contained contained design allows liquid cooling in facilities that may not otherwise allow it or support it. So the other thing that was announced is the Azure Boost, which is a new system that offloads virtualization processes which were traditionally performed by the hypervisor and the host OS, such as networking, storage, and host management. So now this is being offloaded to a purpose-built hardware and software. By separating the hypervisor and the host OS functions from the host infrastructure, Azure Boost enables greater network and storage performance at scale. And this includes security as well by adding another layer of logical isolation and reduces the maintenance impact for future Azure software and hardware upgrades. So the performance is great, as you can see here on the screen. The remote storage up to 12.5 gigabytes per second, local storage 17.3 gigabytes, and the networking is up to 200 gigabits per second as well. So back to Jeremiah. These are all the announcements that we have on the infrastructure side of things.
Actually, I think that was the end of our presentation. So thank you so much to our attendees and all the presenters. I know we shared a lot of information with everyone. This session is really intended to whet your appetite, to get you engaged and thinking about, how you can take leverage of these various technologies. So thank you so much for joining us. Please look for future invites for our future shows. We've shared the links in the chat here. and please come and see us again. Thank you very much.